guys, it's Josh Breen back here with another science tutorial video. Today we'll be doing BCA tables. Now before we get into all this, I'm going to just go over what it means. Before, change, and after, as represented in BCA. So first one, Fe2O3 plus 2Al yields 2Fe plus Al2O3. And the goal is to find out how much of this can we get from 15 grams of 2Fe. So first of all, we need to figure out how many moles are in 15 grams of iron. So this is how we set it up. We're going to say X, and since we're finding moles, and then 15 grams, and then 1 mole equals 55.845. And then we times those together, or divide them actually, 15 divided by this, you get 0.27 moles. So we're gonna say that right here. So 0.27 moles. And then because there's a coefficient of 2 here, and we're trying to find this one, we're gonna actually divide this by 2, because we have to divide it by 2 in order to get an equal number of moles. So that ends up being 0.135. And we don't really have to worry about the change for this one because we're not really doing anything. We're just figuring out how many are actually produced or originally consumed.
So is the change 0 then, Josh?
Huh?
Is the change 0?
I don't understand your question, Alex. Back to the video. All right, so 0.13. So we're gonna have X grams over 0.135, and then once you add up the molar mass of all Fe2O3, you get 1 mole over 159.69. And then once you multiply these together, you're going to get about 21.56 grams, and that's going to be your answer for this first one. So it's very simple. Just keep in mind where you're going to go for the B, C, and A, and also account for the moles. Let's do another one just to practice. All right, for this one, 10 KClO, or actually just KClO3 plus P4 yields P4O10 plus KCl. We already balanced this for you, so you don't have to worry about it, but some you are going to have to be careful to balance them. So in this one, we are given 52.9 grams of KClO3. So we know we're going to have to transfer that to moles for anything in the BCA table. So we're going to set that up real quick. So X moles. 52.9, and then the molar mass of KClO3 is 122.6. So once we divide these two, you get 0.432 moles. 0.432. And because this we know is going to be limiting, we have to add this to the other side. So for example, we're going to have to divide this by 10 and then times 3 to get this. So that's actually going to give you, Alex, do you have a calculation? Okay. No? Okay. 0.432 divided by 3. Let's just, can we calculate?
Yeah, I'll get you.
Real quick?
I'll do it. 0.432 divided by 10 times 3 is 0.1296.
All right, thank you, Alex.
You're welcome.
All right, 0.2196. So if we're trying to find this one, actually this is going to be 0. For before, the products are always going to be 0 because we're yielding this. So the change is actually going to be plus this and plus 0.43. But we don't need to worry about this one because we're trying to find this one. So just like this before, we're going to set up another equation. 0.1296 moles X grams, 1 mole, equals 36.79 grams. That's your final answer. So once you add up the P4O10, you get the molar mass. You put it in here, and then you times by 0.1296, and you simply just get 36.79 grams. And that's basically a rundown of how to do BCA tables.